of vectors. Types of vectors are several that can be classified by the direction and by the magnitude also. The vectors can be classified into the types. Those are the first one is polar vectors. Here the polar vectors means it is also called as a real vector. They do not change with the coordinate system. Change of coordinate system is nothing but the vector whose direction does not change even though coordinate system in which it defines changes. If the coordinate system changes means we know that what is coordinate system. If the body is considered as in between the x y axis, if can be explained that, then that will be the coordinate system. Three coordinates will be there: x axis, y axis, z axis. According to the coordinates, if we specify the direction of the vector, if the direction of coordinate system will changes, then the vector's direction do not change. It will be same. It will move into the same direction. It will not change the direction with the coordinate system. Is called as here the polar vectors like force, momentum, and as well as velocity, acceleration. Those are the examples for the polar vector. Means it's a translational effect. A translational effect means it will be moving in the along a straight line. Each and every particle will moving along the one to parallel to each and every other. They do not change the direction by the coordinate system. So that's why here this is having the translational effects, and its head and tail will be in the lie on the same line. Lie on the line. So that's why there is no change in direction with the coordinate system. By changing the vector do not change it. It is called as a real vector also. It is also called as a real vector also. This is about a polar vector. If in case of the axial vector, axial, we know that axial means by depending on the one another, then it will be this will be the axial vector. It's a rotational effect. It will rotational effect. Whenever the body vector is moving one direction, according to the axial means like this, the rotational. If in case of this will be the anti-clockwise direction. If in case of the clockwise direction, the body will be direction will be in like this. It will changes with the coordinate system. If the coordinate system changes with the effector that rotates due to the rotational effect, the axial vector also it changes its direction. So that's why that type of vectors is called as axial vectors. Like angular velocity means whenever the particle is changing, whenever it is rotational motion, then the velocity keep on changes by the changes of a coordinate system. So that's why here we can say that whenever the particle is in motion, the angular momentum, torque, angular velocity means which is making an angle with the initial one. So that's why here the velocity goes on changing whenever the body is making an angle here that. So that's why angular velocity, torque, angular momentum that goes on changing by the coordinate system. So that's why we can say that there is the vector whose direction changes with the coordinate system in which it is defines the changes. Defined changes is called axial vector. It depends on the rotational effect. It depends on the rotational effect. And the next one is equal vector. Equal vector means if two or more vectors having the same magnitude as moving along the acting in the same direction is called as equal vectors. Either its magnitude be same and acting in the same direction. Either its initial point and end point may be there different. Either the body, its initial points do not be at same position. The two, it is having the at different initial points or at the different end points also. If the vectors are having same magnitude acting along the same direction can be considered as a equal vector like this. That is A bar is equal to B bar. Bar means we can consider that is a vector. And another one is a null or zero vector. This is the most important one. Null and a zero vector. Null or zero vector. This can be considered as a whose vector's magnitude is equal to 0. Means by taking that the magnitude value will becomes a 0. Means here there is no any value. Only it having 0 value. Then that is called as a null and zero vector. So null vector direction we can't determine because of where is when it will be determined like this. There is no any specific direction for this. So it represents by this 0. Number 0 or bar on the top of the arrow on top of the 0 can be considered as this one is the null or a zero vector. The next the examples for the how to understand the null or zero vector. The examples for the null vector are the position vector of a particle at the origin. Means if the particle represented between x and y axis, the particle is there. Then if in case of this is the origin, there is no specified direction at the for the origin. So that's why in that origin, the particle if is at the origin, there is no specified direction. If in case of we are at rest, we are not moving any direction. If we are at rest, the body displacement is equal to 0. Then the direction is indeterminate. So that's why we can say that in the vector will be null vector. Like that, the position vector of particle at the origin will be 0, and as well as the displacement of a stationary object. Means we are in stationary object. Consider we are the stationary object, we are staying at rest, we are not moving in the direction. The direction cannot be indeterminate. So that's why the magnitude will be, there is no displacement. If the particle is at rest, then it will be 0. So that's why here the displacement of a stationary object over any arbitrary interval of time, is called a null or zero vector. And the velocity of a particle at rest, the velocity of a particle is at rest, that will be 0, means the magnitude will be 0, that is a null or zero vector. And as well as the acceleration of a particle moving at a uniform velocity. If the body does not change its velocity, is moving along in some of the direction with a constant velocity or uniform velocity, the acceleration becomes a 0. When the particle is in uniform velocity, its acceleration is a 0. So that's why here the acceleration of a particle moving with a uniform velocity is 0. And once again, the polar vector means the vector whose direction does not change even though the coordinate system it is defined, which defined is changes. That is also called as a real vector. And axial vector means it is a rotational effect, means the vector whose direction changes with the change of coordinate system, which it is defined changes, is called axial vector. Means by changing the coordinate system, then its direction will, the vector direction whose vector's direction will changes, then that is axial vectors. Examples are angular velocity, torque, angular momentum. And the next one is equal vectors, means whose two or more vectors having the same magnitude and same move acting in the same direction. Either maybe its initial or end points are different, but they have to maintain equal magnitude and we act as in the same direction, then that will be considered as equal vectors. And the next one is null or zero vectors, a vector whose magnitude is 0. Means whenever the position vector of a particle at origin and displacement of a particle at a stationary object, displacement vector of a stationary object, and the velocity of a particle is at rest, and the acceleration is 0 whenever the body is moving with a uniform velocity. These are all the examples for the null or zero vector. The next one is a unit vector. So here unit vector, a vector of unit magnitude means 1. If the vector value magnitude will be 1, then that will be considered as unit vector. The unit vector in the direction of a given vector is obtained by the dividing the given vector's magnitude. Like unit vector, if we consider a bar, the unit vector can be denoted as a cap. A is the vector and cap is the unit vector. A cap be the unit vector of A. That can be considered as a cap. It can be called as a cap. So if in case of A is a given vector and the unit vector in the direction of A bar is a cap is equal to A bar by mod A bar. A cap is equal to A bar by mod A bar. It is a unitless and dimensionless vector. It doesn't have any unit and dimension, only it represents the direction only. It means if in case of A bar is the vector, then we can consider that mod A bar. Mod A bar means we know that is root of, if in case of A is equal to AX I bar plus AY J bar, then we can write that AX square plus AY square. Then this will be the magnitude of the vector. So that's why we can write that here the vector's unit vector will be that AXI plus ay j bar by root of ax square plus ay square be the unit vector of a. Means here a cap is equal to a bar by mod a bar, means in the direction of the unit vector of a given, the direction of a given vector is obtained by dividing the given vector with its magnitude. Dividing the given vector with its magnitude. Mod a bar means magnitude. So here it is that a bar by mod a bar is equal to, we can write that is a is equal to ax plus I. We consider that axi plus y ayj. Then the modulus means the value, the length of the vector. We can consider that the magnitude means the length of the vector we are measuring. Mod a bar means modulus of vector means the length of that vector. Modulus of vector means the length of the vector we are finding. So that's why the mod a bar is equal to root of ax square plus ay square. Again we can write like this. So here it is that it's a unitless and dimensionless vector, and it represents only direction only. So that's why here in the right handed coordinate system, I, j, k are considered as unit vectors along the x axis, y axis and z axis. Means in three coordinate system, we are considering this x axis, y axis and it will be the z axis. In the direction of the unit vector is I, it is in the direction of unit vector is j. In the z axis unit vector can be considered as a k. So it's the origin. So like this, whenever the right handed coordinate system, I, j, k are chosen as a unit vectors along the x axis, y axis and z axis. So these I, j, k vectors are called as orthogonal unit vectors. Orthogonal unit vectors or orthonormal vectors also we can consider that. So these are the orthogonal unit vectors or orthonormal vectors also we can be called as. So this is about a unit vector. Once again, the vector whose magnitude is equal to 1 or a unit magnitude, a vector unit magnitude is equal to, that is called as unit vector. To find it is denoted by the a cap, means whose vector is there, a cap be the unit vector, means like whatever the unit vector we are taking, that the cap will given to that vector to show the unit vector. And this is if in case of a considered as a unit vector, then unit vector of a is a cap is equal to, it is divided by the given vector with its magnitude. It is divided by the given vector with its magnitude. Means magnitude of vector means we are finding the length of the vector, modulus of vector. If in case of a given the modulus of vector, the modulus of vector means we are finding the length of that vector. That is here that we will do like this, the modulus of a is equal to root of the terms which is given in the magnitudes which are given in the vector. So here root of ax square plus ay square with the terms which is given in the vector. Then by doing this we can find out the a cap. It's a unitless dimensionless vector and it is represents only one direction. And the I, j, k are the, means the right handed coordinate system, I, j, k are the unit vectors and as well as along the x axis, y axis and z axis. And also here we can say that I, j, k's are orthogonal unit vectors or orthonormal vectors. This is about types of vectors.